Welcome to the video on your final review for square root equations. This is the fourth of 6 videos that are preparing you to do your oral defense. Remember that your oral defense happens in the form of a video while you're taking your multiple choice exam. Just like before, you want to focus your explanation on the bigger picture, which is we're basically just trying to find a number that you are allowed to plug in for x. The new thing with square root equations is that sometimes you can get an extraneous solution. And so although this example itself may not have an extraneous solution, you would want to make sure that you know what the conditions are for that. Clearly, we'll recognize that this is a square root equation, and you'll remember the word extraneous. Other than that, there's a lot of similar concepts that are going to go on here. The first of which is that we want to isolate the square root. In this case, we do that by dividing by 2. And then to actually get rid of the square root symbol, we will square both sides. And I would indicate that probably with parentheses and a squared. I'm allowed to do this because I'm doing the same thing to both sides. I want to do this because the squared symbol and the square root symbol cancel each other out, which means that 5x minus 4 comes down, and the rest is just linear math, pretty simple. Pause the video here and complete the example on the right, the one that says for you. When you press play again, I'll show you the answer. There's the first answer. If you need more time looking at this, pause the video, otherwise I'm moving on. Problem number 2 is also a square root equation. However, it's slightly different because we have 2 different square root symbols, which means I can't isolate like I did above. In this case, I would just directly square each side. And when you do that, continue to use parentheses to remind you. On the right-hand side, we're squaring actually 2 different things. When you square a square root, the insides come down and the square root symbol disappears. When you square a coefficient, it actually multiplies times itself. The common mistake is that people will forget to square that 3. After this, there's another common mistake, which is some people will forget to distribute that 9. You're not going to. You know what to do. The only word that I think we used for this one that we didn't use above was distribute. Again, we could plug the answer in up top and check to make sure that our answer works. When you do that in this example, if you look at plugging 5 over 13 in to 2x minus 1, you'll notice that 2 times 5 over 13 is 10 over 13, which is actually less than 1, which means that when I plug this in up here, this is going to turn into a negative number, which means actually this solution may seem like it works, but the real answer is no solution. Be really clear that the answer is no solution because this solution was extraneous. In other words, it looks like a solution, but it's not really. The answer you would want to put in your video is that this equation has no solution. Okay? Pause the video for a second. When you press play again, I'll show you the answer to your example number B. Here we go for the next one. Okay. Looking at the square root equation, the difference now is that we have a square root on one side and a variable on the other side. The first step is still the same. We're going to square both sides. When we do that, the square root symbol comes away, and we square a binomial, which really means we have to FOIL. If it helps you to write it out 2 times, go for it. Otherwise, you can just FOIL that out. This is now a quadratic equation. I know we started as a square root, but it turns into a quadratic, which means that there are most likely going to be 2 solutions. These 2 solutions turn out to be 4 and negative 4. However, if you think about plugging negative 4 in up top, even without thinking about what happens on the left-hand side, a negative 4 minus 2 would give you an answer of negative 6, and then plugging it in here, negative 4 becomes the square root of 9. In this case, the square root of 9 is 3 times negative 2, is negative 6. So even though you have a negative answer, it doesn't mean it's necessarily extraneous. This one has 2 solutions, and they both work just fine. Pause the video to solve example C. In this case, negative 2 is actually an extraneous solution, and x equals 5 is the only answer. And that would be because if you plug the negative 2 in here, you end up with the square root of 4 equals negative 2. And technically that's not true. The square root of 4 is positive 2. There is another number that multiplies times itself to equal 4, but in this case the only solution is x equals 5.